Okay, so now I'm going to show you yet another piece of code. In this case, I have hooked up two of these infrared sensors, which are mounted down below the robot. Okay, and what they do is on one side of that circuit board, if you look really carefully, one side, actually, let's see, I have another board here. I'll just show you. We'll zoom in on this maybe. On one side, there is an emitter, an infrared emitter, just like you'd see on your TV remote. You can actually watch this with your digital camera if you want when it's plugged in. And on the other side is the detector. Again, just like on your TV remote, one side is looking for the infrared light, one side is sending it. And what happens here is when the device is on, when the sensor is on, it's brightly shining that infrared light down onto the surface. In this case, my surface is white, and the infrared light is reflecting back and it's being detected by the detector. Okay, so if this robot were to run into something like, for example, a black line, it's going to reduce the amount of reflected infrared light, and the sensor is going to go low, or it's going to actually measure a value, and it's going to, you can make a decision based upon it. So what we're going to do in this case is take basically the exact same piece of code from last time, which is over here, and I'm going to add just a couple of pieces to it. Okay, there's nothing in the front here at all. This is identical to the one that just had the bump sensor, and of course all the motor movements are identical. The only change actually happens down here in the main loop. This you probably recognize from the last video. If the bump sensor goes too low, in other words, that high state, that energetic on gets grounded, then it's going to back up and turn. And if it gets the other bump sensor, it's going to back up and turn. Now look, that was a digital read. It's just looking for on or off, high or low. In this case, we're going to have a new command called analog read. Analog read is actually going to get a numeric value. Okay, the brighter it is, the bigger the number. I'm sorry, I think in this case, the other way around. I'm sorry. So if it's very bright, if it's very dark, the number will be large. Okay, if it's very bright, the number will be small. So in this case, I'm going to look at A2 and A3, these two pins, and I'll point those out in a moment. And I'm going to see, hey, if it's greater than 400, in other words, is it dark, then I'm going to back up and turn. And the other sensor is hooked up at A3. And if it is greater than 400, I'm going to back up and turn. So that way the robot, if it reaches a black line in the edge of an arena, it will back up and try to avoid it. Those pins, okay, here's these. I'll show you the sensor here. Okay, there are 3 pins. One of them is going to be power. And actually, if you look carefully at the board itself, you'll see a negative, a positive, and an S, okay, which is ground, supply, and signal. Signal being where the reading is going to come out. It's going to be a change in voltage. I have the white wire hooked up to signal. I have the green wire hooked up to the positive side, and I have the blue wire hooked up to ground. Okay, so back over here on this end where it plugs into your board, you're going to have the green wire plugged into the positive supply, the 5-volt supply. The blue wire goes into ground, and the white goes in to, in this particular case, S2 and S3. Okay, I'm sorry, A2 and A3. A0 and A1 are still hooked up to the bump sensors. And if we go ahead, actually notice, I think I did this last time too, it's currently running. I've just decided to make it stop because I don't want my robot to run away. So it's running through this loop. Okay, it's not low, so it skips it. The first bump sensor. The second bump sensor is not low, so it skips it. The 2 analog sensors are both reflecting off of white, so the values are less than 400, and so it skips it, and then it stops. So we see nothing. But if I slide a black line, okay, you can actually hear it switching directions. And over here. Okay, and of course these bump sensors are still hooked up as well. Alright, so the way you'd want to make your robot go is not have a stop in here. You want that to be a forward. I will say, you can imagine if I wanted, right now it's avoiding a black line. It would be very simple, and I think you could figure out how. If I wanted to make it follow a black line, to race down a black line, for example, on a whiteboard, a line following robot, that would be nothing more than changing the directions of right or left. So if you put the robot on one side of or put the two sensors on either side of a black line, if it bumps into one, it'll steer it away from the line. If it bumps into the other, it steers away from the line, and thus the robot will follow the black line. But let me change this to an F so it goes forward. We'll load it up. And I've got this robot propped. You can't quite see it from your view, but the wheels are not touching. Okay, so it's going forward. And if it ever approached the black line, it would back up and turn. Back up and turn. Okay, and of course this would be turning into. So in this case, this robot is set up to sumo battle. It's going to try to stay inside an arena, and if it bumps into another robot, it's going to turn toward that robot and try to push it over the line. But of course that other robot's got sensors of its own looking down on the line, trying to steer away from the border. So it becomes a rather aggressive push and pull as the robots try to fight each other across the line. So hopefully that gives you a little bit further along, and I will see you again soon.